Okay, so we are going to go over the one-dimensional review guide. I'm going to break this up into 3 sections, one for each page. So we're going to do page 1 first, and then I'll do videos for the other 2 also. So let's just kind of go over the top things for a second, the bullet points. You should be able to explain the difference between distance and displacement. Distance is the whole path that you took to get someplace, whereas displacement is just from where you started to where you ended. It doesn't matter what the path you took to get there. And distance is a scalar value and displacement is a vector. The difference between average speed and instantaneous velocity. So average speed would be over a period of time. It would be your total distance and your total time. And then the instantaneous velocity would be at any particular moment in time, which would be like a speedometer on your car. So that would be your instantaneous velocity. The difference between speed and velocity: speed is a scalar and velocity is a vector. So speed is just how fast you're going, and velocity includes the direction, which in most cases is just a positive or a negative sign. Scalar and vector: scalar is just an amount or a magnitude, and then a vector is the amount with the direction with it, which again in most cases is either just an angle or a positive or negative depending on the situation. Okay. And then also it talks about if your acceleration and your velocity have the same sign, you're getting faster. If they're opposite, then you're slowing down. Acceleration 0 just means that you're going the same speed the whole time. So we're going to go through the questions on this section of the graph. Okay, so the velocity at segment A, velocity is going to be your slope. So your slope here is going to be rise over run. So from here to here, you can take that section because that's going to be the easiest thing to find the slope of. So if you do rise 1, 2, 3 over run 1, 2, 3, that's just 3 over 3, which is 1, and that's meters per second. I'm not super picky on the sig figs on the graphs. This is pretty close to, 3 and 3. I mostly don't give me like 5 decimal points or something like that. 1 or 2 is good. Velocity at segment B. If I look at B, I am not moving because my position is not changing. And what that means is that I have no velocity. So if my position is not changing, then my velocity is 0. 0. We'll put a unit on that. Acceleration at segment D. So acceleration from this graph, the acceleration is the slope of the graph. So from here, we're looking at slope again. So I would go from here to here. So it's going to be rise over run. So your rise 1, 2, 3, 4 over run, which is 2. Which should be 2, and then meters per second squared because you are doing acceleration. And then segment E, again, you're going to take this little chunk. So it's going to be rise over run. So that's a rise of 1 over a run of 3. So it'd be 0.3. Now, this is one of those ones, you could give me 0.3, you could give me 0.33. Don't give me like 3 10 times. Okay, 0.3, 0.33, something like that is good. So do a little bit of estimation with the graph anyway. Which one has a higher velocity, A or C? So to find the velocity, you're gonna look at how steep it is. You could do the math on A and C to get that, or you can just look at it and you can tell that C is steeper. And if C is steeper, then it has a higher velocity. If you're not sure looking at the graph, just find the slope of each one and see which one has the higher slope. At which point is the person slowing down? So slowing down means your velocity is changing. So this section, that section, that section, they're each constant velocities. Over here, I have a changing velocity. If I want slowing down, I want it to be going faster at the beginning than at the end. If this graph is 0, 0, which I probably should have marked, anything that's getting closer to 0 is slowing down. So this is getting faster. That's getting faster, not as quickly, but it is getting faster. On this segment, you're slowing down. So for F, you're getting slower as you go. So F is when you're slowing down. And then 7, how far did you travel during D and E combined? I'm going to use the graph for this. So you want to take these sections, break it into shapes that you know how to find the area of. If you remember how to find the area of a trapezoid, feel free to use this whole thing. If you don't, just break it into 2 triangles and a rectangle. That's what I would probably do. So you have 3 areas here. So we're just going to have 1, 2, 3. So the area of 1 is it's a triangle. So it's going to be base times height over 2. The base is 2. So I'm just going to do right here. 2 times the height, which is 1, 2, 3, 4 over 2, because that's a triangle. And then the section 2 is a rectangle. So it's length times width. So 1, 2, 3 by 1, 2, 3, 4. So 3 times 4. And this one, base times height over 2 again. So 1, 2, 3 times height of 1 over 2. So here, those cancel. So that's 4 plus 3 times 4 is 12 plus 3 over 2 is 1.5. If I add that up, then I get 17.5. That's a lot of sig figs. I would probably round that to 18. If you gave me 17.5, I probably wouldn't take off. 18 is probably closer to being what we want for that. Either one's good. Okay, so that's all of our graph questions. Okay, so again, if you need to go back over things, you can always go back and watch the graphing video again when I walk through that stuff, or look at your notes. So now we're going to go to some more math problem type things. So we're going to go 8, 9, and 10, and then we'll do the rest of them on a separate video. Okay, so we're going to go 8. So let's look at what we have. You walk 12 blocks east in 32 minutes. So I'm going to like start, let's say we start here. East is this way. So let's say I go 12 blocks east. Then I go 3 blocks west. So it's going back part of the way. So it's 3. In 7 minutes, 4 blocks east. So a little past where I had been. In 8 minutes, then 9 blocks west in 25 minutes. Okay, so we're going to find several things. Some of them, the times matter, some of them they don't. So let's just start with distance and displacement. We don't care about the times yet, and then we'll find the time. So A is looking for distance. Distance, I don't care where you went. I just care about the total distance that you traveled. I don't care about direction at all. So that means I don't care if these are pointing left or right. I'm just going to add them together. So it's just 12 plus 3 plus 4 plus 9. That is going to all add up to give you 28. And the units on this is blocks. So 28 blocks is your distance. Your displacement is where you are relative to where you started. So there it does matter which way you're facing. So I'm going to make everything going east positive and everything going west negative. Just kind of matches our convention. So it'll be a positive 12. You turned around, so minus 3. Turned around again, plus 4. Turned around again, minus 9. So if I do 12 minus 3 plus 4 minus 9, I end up with 4 blocks. And it's going to be positive 4 blocks, which is that. If you want to put the east on there, you can also put the east. Oh, my answer key, I didn't write east, but the positive part tells you that it goes with the part of the problem that was going in the positive direction. And then for C and D, we do need to find our total time. I don't tell you you have to do it in seconds, so you can leave it in minutes. So let's find time. Time is going to be 32 plus 7 plus 8 plus 25, which is 72 minutes. Okay, so I'm going to use this time with both my A and my B to get my C and my D. So C is speed. Speed is based on distance. So it's going to be distance, which is 28, over time, which is 72. And so 28 divided by 72 is 0.39 blocks per minute. I'm going to round that to 0.4 because all of our original numbers were just single digits. It wasn't like 9.0. It's just 9. So we're going to go 0.4 blocks per minute. D is our velocity, which is based on our displacement. So that's going to be displacement over time, which is still over 72, but it's just 4 blocks. So 4 divided by 72 is 0.0555. Again, I'm going to stick with one digit. So 0.06 blocks per minute. Again, it's positive, so it's going to go with our positive numbers. You can also put east if you want to for that one. So that's going to be your displacement, your distance, your speed, and your velocity. And again, typically, once we move past this unit, we're pretty much going to use them interchangeably. It is important that you put the right sign on it most of the time, though. So just pay attention to that. Okay, so 9, if you can walk a speed of 3.5 miles per hour, how long would it take you to walk a marathon? So I have given you a speed, which is really kind of an average speed if you look at it, but some sort of velocity. We're going a certain distance. We are not accelerating. We're just walking a certain speed. We may be actually accelerating, but this is going to be like our average. So we have a velocity of 3.5 miles per hour. We have a distance, 26.2 miles. Looking for a time. Okay, now if I look at my units match, so I can use that speed with that distance because they're both in miles. My answer is going to end up being in hours, which is totally fine. I don't ask for it in anything else, so we can just stick with hours. Now, because we're not accelerating, we can use the definition of velocity, which is distance over time. Again, if this was accelerating, we could not use this. So only use this for average velocities or anything that's constant velocity. So this one, I'm going to put my 26.2. Nope, I'm not, because I'm solving for t. So I'm going to go ahead and do that first. So I'm going to multiply the t over here. Multiply my t over here, so it'll cancel it on this side. And I end up with v times t equals delta x. So then I divide the v over. So my t is going to be delta x over v. Now I can plug in. Okay, so now I do 26.2 miles divided by 3.5 miles per hour. Miles are going to cancel. You end up with something over hours, which flips your hours on the top. And you end up with an answer of, look at my next page, 7.5 miles per hour. So it's going to be 7.4857. So we're going to round that. We've got 2 sig figs and 3 sig figs. You always go with the less precise measurement. So we're going to go 7 and then that. So it's going to be 7.5. And this is in hours. 7.5 hours. Okay, then we're going to do number 10, and then we will do a part 2 video. So 10, you can accelerate at, we'll slide right there. You can accelerate at 2.25 meters per second squared. You started out going 10 meters per second, accelerated for 4 seconds. How fast will you be going? How far would you drive? So we have some information, and we're going to find 2 different things from this information. So we're going to write the numbers down, and then we don't need the word problem anymore. So 10, you can accelerate at 2.25 meters per second squared. So that's your A. You started out going 10 meters per second. That's a V naught because it's my initial velocity at the beginning. You accelerate for 4 seconds. That's a time. 4 seconds. How fast will you be going? It's a second velocity. And then how far will you have gone? So we're looking for two things. Let's just stick that up there. So we're going to do two different problems. Let's find a velocity first, because that's what we asked for. So if I look at those letters, ignoring this one, I need an equation that has those things in it but does not have a distance. So we're going to go with this one. Conveniently, it is also already solved for v, which is what we want. So we're going to take our 10, plug it in there, our 2.25, our 4 seconds, multiply that, add 10 to it, I end up with 19 meters per second. Looking at my sig figs, this is my least precise measurement at 2 sig figs. That has 2. Great. Okay, so you're going 19 meters per second at the end. And then how far, we could use either the v squared equation or the other one. We're looking for delta x, so I'm going to go with the one that's solved for delta x already, which would be your v naught t plus 1/2 a t squared. So we can't cancel anything, nothing's 0, but we can start plugging numbers in. So we have 10 times 4 plus 0.5 times 2.25 times 4 squared. Multiply all that out, add the pieces up, I end up with 58 meters, which is 2 sig figs, which matches my 4 seconds there. So that is number 10. So then we'll do page 2 on a separate video.